Am I audible?
Yes, sir.
Okay, let us wait for a couple of minutes. It doesn't seem that people would be joining today. Anyway, let us do the closing discussion since some of you are here. So I'll just quickly touch upon some of the issues that we could not or did not discuss in the in the course so far. Is a slide visible?
Yes, sir.
Okay. Okay. So one is I'll just quickly go through the basic points. These are not really. I mean, this by itself usually is a course, software project management, and the issues therein. Certainly, we choose not to go. I mean, keep that in the main part of the course because that's not something what you are expected to be doing as you join the organization. So you will have to gain some experience, couple of years, maybe 5 years or more before you slowly get into this role. So certainly what the software project management means, I just want to give you a few pointers in terms of what it deals with. So naturally, the basic issue of an IT organization or software organization is creating the software and managing the software. Uh, so a software project, we will say, is the complete procedure of software development, right? So you have requirements gathering to testing and maintenance. This is the part that we have from the developer's perspective have tried to understand to a significant extent. And then it needs to be carried out according to execution methodologies. Depends on the SDLC you are following, depends on the quality compliances that you have to do and so on. It has to be done in a specified period of time, and you have to achieve the intended software product. So that's I mean, the whole of the activity where you do this is a software project by definition. Now, the most key person in a software project is a software project manager. Every project will have a manager. I mean, some companies might call that person as a lead or senior lead or whatever, but there is a designated manager who is pretty aware of the culture of the company, the processes in the company, and the phases of SDLC, given the SDLC model that that particular organization is following for that particular project. So a project manager will closely monitor the development process, prepare and execute different plans that others must follow. He or she is responsible for arranging necessary and adequate resources. So may have to talk to the higher authorities, his or her manager, and so on. Maintain communication with the team members so that all these basic parameters of the project, the cost, resource, time, quality, everything is under control. So in this, a project manager typically has two groups of responsibilities. I'm talking completely about software project management. So naturally, one is managing the project itself, defining its scope, monitoring progress, analyzing risk, and so on. The other is managing people. Maybe in other project management, this may not come up as a key activity because it is not people. Many projects are not people intensive. Maybe managing other resources may be a lot more critical. Managing inventory may be a lot more critical. For example, if you're working on a construction project. But in a software project, besides the management of the project, it is extremely important to manage people, act as a leader, liaison between them, set up the reporting hierarchy, and so on. So these are the two basic tasks, and we will just take a glimpse of what these mean. Now, this is something you might like to retain is software project management is kind of a trade-off, balancing act between the scope of the project and three constraints that it has. One is of quality, another is of time, and another is of cost, right? So these parameters are typically known as the whats of the project. I mean, if you question about the project, then these are the four whats. That is, what are we have been tasked to build? That is the scope, right? You know, 3 functionalities, 20 functionalities, 200 functionalities, and so on. What level of quality it needs to be built to? You know, there's no end to doing the quality. You have been doing assignments, so you must have realized that you can keep on testing, keep on doing things in a better way, and there's still improvements to be done. What time frame do we have to deliver to? That's very important because customer has a specified time frame and you cannot disrespect that. And what are the cost constraints? Obviously, the customer would like to pay as less as possible. You'd like to manage, you'd like to maximize profit from the activity. So you'll have to manage the cost of execution, the cost constraints. So if you look into this, this is typically represented in terms of a triangle. So you have quality, you have schedule, which is time, and you have cost. And at the center is the balancing factor between them, the scope, which is the deliverables, right? So this a key responsibility of the project manager is to keep on managing this triangle on a day-to-day, if not almost hour-to-hour basis. So these three constraints are clear. The quality will define how good the scope is. Scope must be. You have to comply to all the commitments that you have made. The time will talk about the schedule, cost will talk about the budget, of course. So for example, you may have to choose between, the project manager may have to choose between the options of whether she can cut the quality. You know, cut the quality means trade off some of the essential, non-essential requirements for essential requirements. So no. Well, it is a localized software, which means that it has to support multiple languages. But for now, let us just do it for English. So you are, cutting on the quality, you are reducing on the requirements. So you can cut the quality and manage within the given time and cost. Or you can add time, that is delay the project to give more time to complete, often, but not touch the quality. But often if you add time, inherently you may add cost, but maybe less cost. Or you may directly add cost, put in more people, ask your manager that, well, I need more people, you recruit, give incentive to people to do extra work, and so on and so forth. So this is the kind of continual balancing act that the project manager has to keep on doing on the golden triangle. So if you see this view of the golden triangle, there is always, in terms of quality, you can make it worse, you can make it better. Scope can be later or faster. Budget could be costlier or cheaper. And when you choose one, say probably you are not being able to read this properly in your system, you have to blow up. If quality requirements increase and scope is held constant, if you need better quality and the scope has not changed, that is, you have not been able to reduce the deliverables, then the schedule and the budget constraints must be relaxed. So the schedule will have to be delayed, the budget will have to be increased, and so on. So the project manager typically, that is what the role of the project manager in project management is. Then it involves a whole lot of detailed activities. And the basic life cycle that the project manager drives the project through is known as the PMC process: planning, monitoring, and control. That is, you plan that this has to be done, you monitor or measure how much has been done, and based on that, you control, that is, you expedite certain things, you put more people, you reduce people, you negotiate with the customer and all that, and do a new plan. So if you have, if you remember our discussions on things like Agile or Scrum, they are kind of, based on the micro PMC model, where almost at a weekly basis, you are doing this monitoring, you are creating the backlogs and making them on your target and trying to meet those. So the project manager basically drives that. In terms of more detailed activities, naturally, the project manager has to do the planning, has to manage the scope of deliverables in terms of what all items it will involve, what are the divisions that are possible, how to control that. And another big factor that the project manager has to deal with is often estimation, because you are always talking about future. When you are talking about this project planning, the project is still not implemented, so you do not know, how how do you know that how big this will be, how many people will it need, what would be the size of the software that you are going to build, and as it keeps on building, how do you keep on tracking these parameters and doing the estimation. So there are this is a big chunk of software engineering, the project estimation. If you look into multiple courses of software engineering, you will see that hundreds of pages, there are hundreds of books specifically on project estimation, on quality estimation, on reliability estimation, on time estimation, significantly on cost estimation, because that's very, very critical. Because if you have underestimated the cost, then it is very likely that your project will end up being in red. If you have overestimated the cost, then it is very likely that you will lose the tender against your competitor, and so on and so forth. So there are several measures of software estimation which are used. The most common is, of course, what is called LOC, or lines of code, that you estimate. Typically, the more practical unit is KLOC, thousands of lines of code. Then other model is function points. Function points are not exactly functions, but those are the identifiable action points in the software. So there are function point models. Then there are models for doing effort estimation. Some of them are statistical, like the Putnam model, which bases the time and effort with software size, and is kind of decided based on past experience. COCOMO is a very popular model for effort estimation. For estimating and tracking time, you typically do a work breakdown structure, which is a very well accepted tool. So you take the whole work, say one module, you break it down into smaller, you start getting into the people that you have, you assign tasks to people and plan on that and see how they will break down, and so that you can come to almost a work breakdown unit which goes up to a day or maybe a couple of hours. And cost estimation naturally have a lot of parameters, is one of the most complex part and needs the most experienced brain to be involved in this. Some of the typical tools that project management will use, you may learn about these tools even though you are not managing a project. It's good, these tools are useful in managing your own work as well, like NatChart, which shows a schedule. So if you see this, you can use NatChart tool, or what we often do is we just use an Excel and do the marking. So on the rows are the different activities, and on the columns are the time units, here shown in terms of weeks. And the shading shows the period over which this activity goes on. So that tells you, in terms of the row, it tells you when does an activity start and when does it end. And in terms of column, it says that in a given week, what are the activities that are happening. There could be dependencies between them, which are shown as arrows, not shown in this diagram, but shown as arrows, that this activity can start only after that activity has ended, and so on and so forth. Then there's a more, structured graphical model, comes from typically the operations research domain, which you call the PART chart, program evaluation and review technique charts, which goes on these definitions that this is 10 units, and you do this action, it will take 5 days and take you here, where you earn 20 units, and this will take you 3 days, this will take you 4 days, and so on. So starting from the beginning to the end, you find out what is your time critical path. For example, what is the minimum time? I mean, if you have, say, infinite resources, what is the minimum time to go from first to the end? If you go along this path, it is 5 plus 6 plus 3, 9 days. If you go along this 3 plus 4 plus 3, which is 10 days, right? So this is 10 days. So this is the critical path, right? Because you have to finish this path at the beginning to be able to. So you cannot give an assurance of delivering this project in less than 10 days, because that's the minimum you are going to take. Then you use, then the project manager will use some resource histograms and so on. So there are several other tools. So just I outlined a few just to give you an idea. The other part is obviously people management, which involves identifying talent, acquiring them, using them in an optimal way, and most importantly, retaining the talent. Attrition is a right now, sitting in the second year, you are concerned that whether you will get a good placement. But once you are placed, you will immediately be concerned as to when can you get a better offer, right? So attrition is a primary issue that the project manager has to deal with. And several surveys over time have shown that obviously there are several parameters people look at wherever they work, and the parameters on which they might change. So one certainly is the package, the money, that's important, but after a while it does not remain a primary factor. What technologies people are working with, what kind of projects people are working with are critical factors. People want to always keep on learning. They want to work on latest technologies and so on. These are important. But as it turns out, after several surveys in several organizations and several projects, is the primary factor people work for in the project or in an organization are their manager. You may have a great technology, you may have a great project, but if you do not have a good manager, then you will not have a good life. You will not have a good experience. So for the project manager, it is very critical to communicate with the people and manage them. There are certain key components of people management. I've just listed them. I mean, I'll not go through these. What are the, I mean, these are kind of the traits of a project manager in the people management skills that must build a lot of trust with the employees. Employees must be able to trust you. You must trust the employee. There should be empathy, feeling for the co-worker. You must be able to motivate every employee depending on whatever he or she gets motivated with. Continuous appreciation and feedback is a very required process. You must keep on, the knowledge-seeking behavior of your team always very active, and so on. Right. So, I guess, I mean, this is not certainly talking about software project management, but before I close on the course, I just wanted to tell you that there are big areas of software engineering which people, I mean, as you grow up, you will need to learn. You will learn on the job. You will learn from your seniors, and possibly will learn through several studies that you make. And that is where the real challenges, bigger challenges come up. For at your level, the challenges are, how do you write a requirements right? How do you do a design properly? How do you create a test plan in the right manner? What is a good test suites, and so on and so forth. Okay. So let me stop here and ask if there are questions.
So are part charts actually used in software companies now? Because I have heard it is used quite a lot in other companies like like manufacturing companies, basically.
See, there is no global standard for what you use, right? Even as I said, that a startup company might just keep on using Excel. You can do quite a bit of part chart is more like an analysis process. So many of the project management tools have that as built in, so you may not be using that separately. But in a software organization or in a software project, if the project is big, then a higher order, you don't do part chart for low level stuff. Maybe things that you'll be doing in a week, you will not be doing that. But for things that will run over months and so on, organizations may be doing part charts. These are representative tools, of course. There are hundreds of tools, open source as well as commercial. Of course, you can manage a good lot of stuff with open source tools themselves, and you should try to do that. Okay.
Yes, sir. Because I've noticed like there's quite a bit of formalism in the software engineering research side, but like how much of that formalism is actually used in industry? That I used to wonder. Like say,
see,
yeah.
if you ask my very frank opinion, having run the company for 12 years, about 100 people, our unit used to do about, at that time, about between 2 to 4 crores turnover. We have not used those formalisms. There are issues are one is primarily that often, unless you are really a large company and driving your own product, often what it turns out that you just do not have that much of time to do so much of analysis. Right? The customer tells you this is what I need, and quote me now in the second half. You will negotiate for 2 days, delay for another day, and within 3 days your quote with details, rough design is going out. There's no time to do that much of analysis. It has to be more on experience, so more on analysis of past data in your organization with that client. You have to build in what is the client looking at. For example, the models would never build in that what is the cost client is expecting.
Yeah,
that's a big parameter in quotation. You may do all that model and come to that this is $100,000.
Will the customer pay?
And the customer has a budget of $30,000, right? So whole of your exercise is going to go waste. So the critical information is to have an estimate that, okay, the customer is looking somewhere around $30,000, right? So your estimation may go a little bit backward, telling the customer that, look, this is the kind of things which jacks up your cost, but these 3 requirements you are talking of are really decorative, but takes a lot of effort and money. So why not keep it for the future? So it is a very interactive, negotiative. That's why it needs a whole lot of experience. Of course, I have not worked in companies like Google or Microsoft. I cannot share that experience, but having run our own startup for 10, 11 years, I can tell you that it was most often it was, whenever the marketing will bring the contact, marketing will often come with a ballpark number that, well, this is the kind of, I mean, that number could be in terms of dollars. That could be a combination of dollar and time deadline. It could be in terms of man months. It could be in terms of resource level plus man month and so on. And you have to fit your quotation according to that, and have to fit in your, first level of, quick design analysis, because once you quote, it is frozen. So after that, if you find that you have not understood the problem clearly, then you are gone. Your job certainly is at stake, but maybe more. So these kind of things are very complex, and it is good to have tools for analysis. I'm sure a lot of the AI that's happening today are using some of these techniques. But you do need a lot of direct experience to actually use. So that's the reason you'll see that while a lot of software engineering books or a lot of software engineering syllabus teaches a lot of these models and so on. So I chose to completely stay away from all that, because that's not what I could see myself or my people use even 10% of that time. But we spent our nights over debugging. We spent our weekends, our Durga Puja vacation on debugging, on quality assurance, on stabilizing the software, on finding out good design interfaces and so on and so forth. So I think, at least at the first level, that is where you should focus on. Then by the time you reach a level where you need to deal with this, I'm sure the technology itself will change. It's changing so fast. And 5 years from now, there'll be more things people are talking about. That's my opinion. Don't take it as a book saying this. And I do have a lot of respect for the authors of the books, but this is the reality on the ground.
Yeah, and also the bigger companies you mentioned, like Microsoft, Google, they are product-based companies, so they don't really sell their software to customers. They don't have to do negotiation with the customer more within the
Yes,
company.
they have to. They have to.
Does Google even have?
See, customer is a concept. Customer is not an individual. Customer is a concept. So for a product, your customer is your sales and marketing team. They will come back, do surveys, come back and say for this kind of a product, how much a general customer will be ready to pay. So they say, if I go out with the Office suite, someone is ready to pay $100. So, and we are expecting to sell about 1 million copies. That tells you how much money you have. So customer, and those are more difficult customers. We always say that internal customers are more difficult to do a sales with, because they know the organization, right? But customers will have to be there. This whole model, do not just cast it on a physical structure, but the whole model is how the business has to work. So you make an excellent product at a price level where there is no buyer, certainly it's not going to work. So it's not that the product companies have an even difficult job, because they do not even know the customer. So they are guesstimating what the customer is likely to be able to pay and where do you want to position. Right? For example, take for a very simple example. You think of machines built by Lenovo, HP, or desktops, laptops, and machines built by Apple, right? And Apple's machine costs 4 times as much, 3 to 4 times as much, right? Yeah. Both sell in the market. Strategies are very different. Apple, of course, does not sell the volume that the other products will sell to. But that is the reason there is only one Apple. They have not been a competitor. They give a quality which they are targeting that segment of the market only. And that is the business strategy. So when Elon Musk agreed to enter India, he did remark that we'll have to wait, because it's not that we cannot bring down the price of Tesla to a large number of Indian customers, but that's not a price point where we want to operate right now in the world. I want to charge for the premium and let it be an exclusive car. So the product is a very difficult positioning situation, right? So all these you will have to keep in mind.
As well.
Matter of philosophy as well. So if you want to grow more in that, obviously you will grow away from software. That does not matter. But if you grow more than that, and that's why people take IM degrees and so on. So when me and my son debate, it goes perpendicular because he's an IT engineer with an IM MBA, runs his own company. So he also does software, he also does ML, he also does deep learning, but his perspective of looking at things are very different from mine. He just does not care whether this solution has a validity or not. He's most concerned is his customer happy getting that answer, because he could get him that answer, in half the time compared to 10 people that the customer were using. So those are the kind of things that take out. So that's about engineering. Engineering is never without management. Management can be without engineering also, because you can manage other things. But engineering is a life process. It needs management very deeply, right? So that's where these issues come in. Okay, just before we totally close the course, I just want to talk a little bit about something which I find very interesting. That is AI. So just maybe last 10 minutes, 15 minutes of little bit of that. Can you see the slide? I hope so.
Yes, sir.
Yes, sir.
So I just called it smart software engineering. This is not a formal term, and most of the books you will not find this yet. So the basic question is, you have done so much of software engineering, and we all are after AI, machine learning, and so on. The question is, how does AI is playing a role in everything? How does it play a role in software engineering? So this is the Software Engineering Institute of Carnegie Mellon talks about this model, which I like, between artificial intelligence and software engineering. So AI has applications in software engineering, which they called intelligent software engineering. And software engineering is, of course, required in building smarter AI systems, which they called intelligent software engineering. Right? So that's a kind of, so I'll try to take a little look into the first part. That is, what is the role that AI can play in software engineering? And it is changing the whole almost universe. And I would say that last 2 to 3 years there has been a big surge in this, with papers starting to come out somewhere around 2018-19, and even during COVID, and at present a lot of papers are coming out and a lot of activities happening. So if you look at this life cycle, this is what we have done. SDLC on the left, planning, analysis, design, implementation, integration, maintenance, go over that. And on right, this is mapped from, it is actually from this blog. So you can see a better image going there. As you go around this, you can see that if you are going from, say, software project planning to analysis, you need to predict problems and risks by expert system, which is what people are working on. Because risk containment is a big question. If you're going from analysis to design, you look at structured access to design patterns, free creative potential of human developers, still less of intervention by the AI has been possible. And it goes on like that. But for when you come from maintenance to software planning back again, people are trying out big data-based analysis as to what are the things that are challenges in maintenance and how should you plan to make them better. So in each one of these, project planning, analysis, design, implementation, there has been several work being done by people in these. So I'll just briefly touch upon one research that we have been doing for last couple of years. We call it Smart KT. So this is a doctoral research, and many BTech and MTech students have also worked on this. So the core issue is in an organization, knowledge transfer, or known as KT for short, is a serious problem. What it means is, you have developed a software, it goes into deployment, and then it's in maintenance. So naturally, you scale down your original development team, and it continues to be maintained. I mean, customer continues to use it, and maybe after 1 year, 2 years, customer come back with a bug. Customer come back with some, requests for upgrade, new features. Now, at that time, possibly the original team members are not there. They have moved to other projects because there was not much activity here. And you put a new person into that. Now that person does not know the project, what has gone in. So that person needs to be educated about the project. That person may be an expert developer, a good software engineer, and so on, but not knowledgeable about that project. And that process of transferring the project knowledge to the new entrant is known as the knowledge transfer, or KT. Right? So the question is, where does that person learn from? Well, documentation is there. Documentation is available, but often they are dated. Documentation will be there when possibly the original project was done. After that, changes have happened. After that, bugs have been fixed, and documentation may not have been updated. So often they are dated. Design documentation that you have, that may be broken because you have made changes for subsequent upgrades or bug fixes. Code comments may become irrelevant. Original project team experts are unavailable. So it's known for sure that the knowledge transfer is a big problem. So what the engineer is left with is she has some broken documents, some project documents, and she has a whole lot of code. The advantage is she has a project which runs correctly on a large test suite. So it has a source code, it has an executable, it runs on a big test suite, you know the goldens of those test suites and so on. So everything that way is available. And what the person has to do to learn about the project is to basically go through the different parts of the code, run it through the debugger to see how the runtime behavior is. If the code is multi-threaded, it's a nightmare because you cannot easily debug a multi-threaded code unless you know what is your threading model and so on. It makes the learning very, very difficult. So what we are trying to do in Smart KT, Smart Knowledge Transfer, is we consider all of these project components as knowledge sources. And we use extractors to extract the knowledge. For example, since it has a perfectly executing code, we run it and we use a kind of runtime event tracer called PIN to see what events are happening and log those events. So that tells you that over this input, what events have happened. You take hundreds of inputs, thousands of inputs, you will have a log of what things have gone through, which is kind of a signature of how the program behaves at the execution time. You certainly have the source code. So you can analyze the source code through different analyzers like the program analyzers and so on, get different information about the program structure, all that. You already have coverage information on all those. Most interestingly, you have comments. So the question is, comments are natural language kind of phrases littered with program symbols. So the question is, can you analyze the comments with linguistic techniques, NLP techniques, and extract information, more information about that? For example, I have an sorting algorithm. The comment might have said that this is a Mart sort algorithm, but otherwise it may not be clear. So I can use comments. I can use comments to find out what does a particular variable mean. I have a variable called number. The comment says it's number of times you have visited the zoo, right? So the comment can tell you that semantic information. You can dig into the bug tracker to see what are the traces of things that have happened. You can dig into the version control system, the emails. So taking each one of them as source, you can have extractors of information. And then you start, kind of modeling them in terms of certain higher order feature primitives and try to extract knowledge, because you have, large volume of these available, and build a knowledge graph. So this is kind of like Google looks at, millions of documents and makes knowledge graphs based on different keywords. Here you are making a knowledge graph for a overall software project, and then you put a, smart query engine using some languages called SparkQL and so on, smart query engine, boom, where the programmer can ask questions and get answers without actually going through the code and the debugger and all that. So that's kind of the vision, and the prototype of the system is already built. It is getting published, and we are working on refinement. So this is I consider a very good, strong example for what AI and machine learning can do for software engineering. Of course, there are several others. Like here I have listed a few common tools which are used, which are AI enabled and can be used for software design, testing, GUI testing, decision making, and so on. Right, so there are some more references here. This is in case you are interested. I can take a look at that. Very interestingly, I was looking at that who first brought in AI to software engineering. It dates back to 1987 when the first tutorial paper was written, but nothing happened after that for nearly 25 years. So people do visualize, but of course there's a lot of work also happening in terms of software engineering for AI. How do you, for example, software engineering, particularly for machine learning and so on. Microsoft and others are proposing different software engineering techniques which are more appropriate for building machine learning systems, AI systems. So you could look at those. And finally, some universities have started talking about artificial intelligence engineering, AI engineering, which is going to be a combination of all of these. So with these words, I think I'll close. If there are quick questions, I'll take. Otherwise, I just wanted to give you a future vision of my expectation, at least, of the heavy use of AI in software engineering. And that could be, if you are, as you go out and start working, this could be, if it interests you, that could be a good area to work on, whether you are in an industry or you are in academia. How software engineering, still the productivity of software engineers are very, very low. The knowledge transfer is a very slow process. More than 70% of the time is going in maintenance, most of which are mundane. So there is a big scope, and it is significantly a human intelligence activity, right? So it's not algorithmically solvable so easily. Otherwise, people would have solved that. So AI has a big opportunity in software engineering in different levels to build tools, to build framework, which can really improve the two key factors of any company. That is the productivity of its developers and the quality of its product. If you can do that for your startup or for your organization, I think you will add a lot of value. Any I mean, this is not, I mean, you can comment. This is not the kind of discussion that you can have questions on. Anything that you would like to add? No?
Sir, so the major problem which I thought like is being faced is because of incomplete documentation, like as it was raised. So is it just because of ignorance or like hard deadlines where companies try to prioritize completion of the project and documentation later on gets ignored? Like nobody.
You know, deadline is a naturally a very serious problem, right? Often the deadlines are completely infeasible. So you cannot blame the developer if the developer is not being able to complete the documentation. So what's coming up more is that documentation will need to happen at multiple levels, and naturally, you know, certain level of abstract documentation, which is at the analysis design level, must be done with a with proper tools. For example, if you use a proper UML tool, then doing a UML based specification or modeling is much less time taking than if you are just writing it down, but it's more expressive in that way. Coming to the code, there are a lot of documentation automation that people are talking of. There are certain things are in terms of practices, like when I try to write, and that's you know, maybe many people do that, is I prefer to use variable names which may be a little long, but which says everything about that variable, so that the name itself is a documentation, because you need to type it once. Rest of it you are just doing copy paste, or even not even doing copy paste. It's a smart fill up which works. But instead of giving variables short name, if you can give them really semantic name which are easy to read, again, use camel case or underscore separator between the different words in the variable name, so that somebody can just look at it and read. That's a good clue to documentation. Documentation giving some, leaving some tags for automatic document generator is another good idea. So there are a few things which you can practice better, and of course the way you write the code in several places, if you structure the code in a proper way, then the need for documentation goes less. For example, it's necessarily easy to read Python, because it does not allow you to get a Python code compiled unless it is properly indented. Once you indent a code properly, its readability immediately improves. So these are things. See, the question is not only about the documentation. That's just one component. But what you are trying to improve is the readability. What you are trying to improve is how easily comprehensible is the code, the program that you have written. Right. So these are ways you can make it better. But of course, a proper documentation is going to take time, and it takes. Often in project pressure, it takes a backseat, unless you are working on product where the rules are very strict. In fact, some companies, typically the big companies, have very strict check-in rules which say that unless you have completed that part of the documentation, you are not allowed to check in. So then you are forced to do that, and your timeline will always come in that way. And last but not the least, this is another area where a lot of people are doing the work, both in terms of validating documentation against the code, and the other is creating how much of automated documentation can you do. So again, AI coming into the play. So this is kind of the I should say the current status. There may be more happening. That's that disadvantage. Currently, I'm not in the industry, so absolutely latest practices I may have fallen back. Okay, I think we have had an intense course in a short period of time. I don't know how much it has been useful to you. I've tried to give the more industry specific experience and exposure to it. So let me know through your feedback as to things that we can improve in the next time. And all the best for the remaining of the semester and for your summer break. Take care. And if you face or if you see any issues in software development, design, software engineering, even beyond this course, or you find something interesting that's happening there, please drop me a mail. I would love to interact and know more about it. Okay, all the best. Let us close now. Thank you. So this will of course be the last theory class, because today is the last class of the semester. Beyond this, if you have to interact, please write an email, or we can set up a separate call in case you need to discuss anything. Okay. Thank you. Bye.